Okay, I'm going to do a quick summary of 4.1. There's several things that are asked in 4.1. They ask the first part, they want you to make sure that you know the difference between some vocabulary words like leading term, leading coefficient, and degree, and the name of the polynomial. So let me talk to you about a few things. A constant function is one that just has a number. So if you see a function f of x, g of x, whatever, and just a number, that's called a constant function. Then we can have a linear function, and that would be something like g of x equals 3x minus 7. It would have an x. The x would be the first power. So that's a linear function. Quadratics, you spent most of Algebra 2 studying quadratic functions, and that would be something with an x squared. So 5x squared plus 2x plus 3. If it has an x squared, it's a quadratic, or if that's the highest power. A cubic would have an x cubed, and it may have some other things after that, but it's got to have at least a cube. A quartic has an x to the fourth. It can have other things after that if you want it to have other things. Anything above the fourth power, we're just going to call a polynomial function. And you don't have to know any names beyond the fourth power. Figure out why that's blinking. Okay. When you have a polynomial function such as, I'll just make one up, f of x equals 4x to the third minus 2x squared plus 5x plus 3. If I were to say, what is the leading term? Terms are separated by plus and minuses, so 4x cubed is a term, negative 2x squared is a term, 5x is a term, and 3 is a term. My leading term is the one with the highest power, so my leading term is 4x to the third power. The leading coefficient, here's another vocabulary word, a coefficient is a number in front of a variable, so the leading coefficient is that 4. It's the number in front of that leads off your leading term. The degree of this polynomial is the highest exponent, so the degree of this polynomial is 3, and this is a cubic polynomial. Now, knowing the leading coefficient and the degree can help me determine the end behaviors of the graphs. Let me explain to you about end behaviors. Not there. Here we go. End behaviors. Well, sorry about that. End behaviors. To figure out what a graph is doing on the right, you look at the leading coefficient. If the leading coefficient, we just talked about that, if it is positive, then that graph is going to go up on the right. If the leading coefficient is negative, then that graph is going to go down on the right. So if I go back over here to the graph we were just looking at, or the equation we were looking at, the leading coefficient is positive. So that means on the right of this graph, it's going to be going up. Now I've got to figure out what it's doing on the left. How do we figure out left? For the left, we look at the degree of the function. If the function has a degree that's even, it's going to do the same thing. It's either going to go both up or it's going to go both down. That's for degree even. So you would look at what it's doing on the right and it's going to do the same thing on the left. If the degree is odd, they do opposite things. Like this, like a cubic function is an example of an odd function. So you look at what it's doing on the right and you do the opposite on the left. So over here, the degree is 3, which is an odd number, so it has to do the opposite thing. So since it's up on the right, that means it would be down on the left. And that's what the end behaviors for this particular graph would look like. The other thing that you had to do in 4.1 was find the zeros and their multiplicities. So let me give you an example of one. Problem 33 out of your textbook looks like a pretty good one. F of x equals x cubed times x minus 1 squared times x plus 4. These are the factors. X is a factor 3 times, x minus 1 is a factor twice, and x plus 4 is a factor once. There's not a number out here, so we understand it to be a once. So to find the zeros, you set these factors equal to 0. So I'd set x equals to 0, and that would be a factor 3 times. So I say that it has a multiplicity of 3. X equals 0 is a factor with a multiplicity of 3. X minus 1 is a factor. If I set that equal to 0 and solve it, I get that x equals 1, and that happens twice. So x equals 0 with a multiplicity of 3. X equals 1 because x minus 1 is a factor. That happens twice. And then if I set x plus 4 equals a 0 and solve it, I get negative 4. And you can write multiplicity 1, or you can just write x equals negative 4. It just happens one time. And that's how you do that one. Okay, let's look at some word problems. I had some questions about those. I'll start with problem number 61. 61 says the number of milk cows on farms in the United States peaked at 24,940,000 in 1940 and decreased to 9,058,000 in 2006. They give you this really long quartic function where x is the number of years since 1900 and can be used to estimate from 1900 to 2006. And they want us to estimate the milk cows in 1960 and in 1980. So I'm going to type this equation in. I'm going to pause it because it's really long. All right, I'm back. I've typed this entire equation in. It's really, really long, but it's in there. And I am going to look at the table. Now remember they said that, uh-oh, I typed something wrong. I can always hit go to and it'll show me where I typed it wrong. Oh, here at the end, I guess I have something. Delete, maybe. Oh, plus 7.7440683. Oh, it was, I was supposed to have an X there and I had a arrow or something. Okay, that should work. Now let's go to the table. All right, they said that X in this problem is the number of years since 1900. And so like 10 would be 1910, 20 would be 1920. They want to know how many were there in 1960 and in 1980. And I can scroll down, but honestly, a faster way would be to change it from auto to ask. When this stops here in a second, I'll do that. I'm going to go to second window, which is my table setup, and I'm going to change my independent from auto, which is what it's on now, to ask, and go back to the table. They want to know in 1960, so that would be 60 years after 1900, and I get 19,325 cows and 1,000 cows, so that actually would be 19,325,000 because this is the number of thousands of cows. And then 1980 would be 11,460,000 cows because it's 11,460 thousands of cows. So that's number 61. Number 62 talks about a stone being thrown downward. So I think we looked at this in some of your classes. They end up telling me that the height is 294. And if you look at that equation, S of t stands for the height. How far is it going? And so here's my equation. They want to know how long would it take to hit the ground. So I'm going to solve and see when would this equal 0. So I'm going to go back and use my calculator. And in my y equals, I'm going to have 4.9x squared plus 34.3x minus 294. And I want to see how long is it going to take it to reach 0. And it's right over in here when it graphs here in a second. And if you go to your table, which I don't have on auto right now, but I can change it to auto. Go to my table, I'll find out it's after 5 seconds. And if you aren't able to find it in your table, you can always do left bound and right bound and find the 0 of this function. So at 5 it's 0. So it's going too far, but you could also put plus 294 because that's where you're starting from, and then see how long it would take to get it to a distance of 0. And then the graph's going to be coming down and take 5 seconds to hit 0. Either way would work to give you the same answer. 63 is one about tornadoes. They give you the function. It's really long to type in, but as long as you type it correctly. Now, X in number 63, X is the number of years since 1998. So if you're wanting to find 63, sorry, if you're wanting to find 1998, your X would be 0. If you're wanting to find 2001, your X would be 3. So you plug in 3 and see what you get. And in 2006, your X would be 8. And you just plug that in and see what you get. Same thing for 64. I do not see any other issues in here. But if you have any specific questions on these, if you will let me know, I will be glad to either work out that problem or spend some more time on it. Tell you what, there's two more that I want to look at. Problem number 70 and then problem 78. I wanted to look at right quick. 70, and I know I'm over 10 minutes, which I really don't like to do, but I'm going to put this in here. The weight threshold here, weight is in pounds, H is a person's height. They want to know what would the threshold weight be for a person who is 5 feet 7 inches tall. But they want you to put their height in inches. So if they're 5 feet 7, that would be how many inches? Well, there's 12 inches in a foot. So 5 times 12, I'm going to go to a regular screen. 5 times 12 is 60. So 5 feet 7 inches would be 67 inches. So I'm going to put 67 for the height. And all you do here to find the weight is you do 67 divided by 12.3 and close that and then cube that. And I'll get about 162 pounds. You guys, I don't know if this operating system's updated, but on yours, yep, here we go. Watch this. You could do it this way. You want to make sure that I probably should have put parentheses in first. But you can also write your fractions this way if you're worried about making sure that you have your fractions done right. 67 over 12.3. If you don't like doing the slash, you can always do this and do your problem that way. So that's problem 70. You're just plugging in 67 for the height. Now 78 talks about number of farms, and they want you to find a graphing calculator to fit a quadratic, a cubic, and a quartic function to the data. And they want you to use each function to estimate the acreage in 2010 and 2015. And the years are going to be, X is going to be the number of years since 1900. So go to Stat, Enter. And what we're going to do is instead of typing in 1900, I'm going to put 0. And instead of putting in 1910, I'm going to put 10. And put all these in the calculator. For 2000, I'm going to put 100. For 2003, I'm going to put 103. For 2005, I'm going to put 105. And then I'll put the acreage just like it's given to me. If you'll notice, it looks like farms are getting bigger, and I bet if we looked at number of farms, they would be going down. But what's happening is the farms across our country are getting bigger, but you've got fewer people farming. And you just want to check and make sure that you have the same number on the left as you do the right, and I do. So they want me to find a quadratic, a cubic, and a quartic function. So first I do stat, over to calculate, and I want to do quadratic. That's number 5. 5, and my X list is in L1, my Y list is in L2. If you want to go ahead and store it in your calculator, you don't have to do this. You can just write it down. But if you want to store it, you can push this vars key, go over to yvars, and hit enter. I'm going to put this one in Y1. So the quadratic equation is this, y equals 0.11x squared plus 2.25x plus 110.4. Then they want me to find a cubic model, stat calc number 6. I'm going to store this one in Y2 so I'll have it. And calculate that. Here's my cubic model. Now notice with the cubic model it looks a little bit different than quadratic because you've got a number in front of the x cubed and a number in front of the x squared and a number in front of the x, and then you've got a constant. and it's already in my Y2. And now I'm going to come up with a quartic function. Stat calc quartic is number 7, and I'm going to store this one in Y3. So I push vars, I go over to Y-vars, push function, and I choose number 3 and calculate it. So here's my quartic regression, and notice there is a x to the fourth, x to the third, x squared, and x, and that one's not good because this is really, really small. E negative 5 means 0.0000152, so it's negative 0.0000152. It's really almost 0. Okay, if they want me to find the averages in 2010 and 2015, instead of trying to scroll down the table, which I could do, here's my table for all of these. Y1 is the quadratic, Y2 is the cubic, Y3 is the quartic. Instead of scrolling down, I'm going to change my table setup from auto to ask. And they want me to find 2010, which would be year 110 after 1990. So I get 503, 425, 385 for the average acreages. And then in 2015, that'd be 115, and I get 528, 400, and 320, and determine which gives the most realistic estimates. And that's something that you'll have to decide which one is more realistic for this particular data. We can talk about that in class, but hopefully that's a good overview for you of 4.1 and the word problems.